the number of significant figures. Someone had asked me for this as a specific topic, so I'm going to give you significant digits as a specific topic. Remember, it's lab application. It really depends on the tool you're using, like the graduated cylinder that I showed in the other video. If your tool, you can only be as accurate as your tool. So these are actually measurements that had to have been taken from a tool, or you're doing the math application for it. So if you want to memorize the rules, feel free to memorize the rules. Otherwise, let's try to figure this out logically. Now, if I'm looking at this number, I'm looking at a whole number and then a couple of placeholders. This number could have been 2 times 10 to the negative 2. So I could have taken like 2 centimeters and changed it to meters, which would have caused me to have this type of reading. So the only digit here that is significant is this 2. That's it. So this number has one significant digit. This number, however, has 2 significant digits, because this digit tells me that I actually saw it when it was measured. Like when I put it on a balance, it measured at 20, 20, so 0 was the measurement, and I might have just converted it to a decimal number. So these are just placeholders. So I have 2 significant digits. This one has 3 significant digits. The easy part is the numbers. If it's a number greater than 0, you know it's automatically significant. But see, this number in between 2 numbers tells me that it was measured as well, that it was seen by what piece of equipment it was used, measured with. So this one has 3 significant digits. This one has 4 significant digits. By putting that decimal there, that tells me that I saw this 0. It was like right on the line, or it measured in a balance. So this one has 4 significant digits. This 5,000 does not have a decimal, so that tells me that it could have been rounded. So these zeros are not significant. I could write this as 5 times 10 to the third. So it only has 1 significant digit. That's it, 1 significant digit. Now this decimal tells me that this one actually was seen by all of these, so this one has 4 significant digits. This decimal with these 2 places tell me that those are significant, so there's 6 significant digits here. Again, these are just placeholders, so you don't even need them. There's only 1 significant digit, because I could write this as 5 times 10 to the negative 4. This one has 1, 2, 3, 4 significant digits. This first 0 is just a placeholder. And this one has 5 significant digits, because there's 2 numbers greater than 0 with those zeros in between. So those are all significant. So that's the basic rules. Now what we're going to do is we're going to draw a line over the last digit that is significant, and then write the number of significant digits. Because there's no decimal here, 4 is the last significant digit. So these are significant. So there are 3 significant digits. These are placeholders, so the significant digits are right here. The last one is that one. So there's 3 significant digits. All of these are significant because they're numbers greater than 0. So there's 4 significant digits. All of these are significant because there's a decimal, and the zeros after the decimal and to the right of a number are significant because this measured it exactly to that value. So there's 4 significant digits here. Again, the last one being there. Here's the last significant digit. So this one's a placeholder. So it's 1, 2, 3, 4, 5 significant digits. There is no decimal here, so this is the last significant digit. There are 3 significant digits. This one has 2 significant digits. This one has 2, another 3, and another 3 because of this decimal. So there are 8 significant digits here, this 0 being the last significant digit. There are 3 significant digits here, and there are 3 significant digits there. Now the other question would be, how would we use this information? How would we actually apply the significant digits? Well, there's 2 things that you need to know when you're using it, when you're multiplying and dividing or adding and subtracting. When you're multiplying and dividing, let's say I have 4.2 times 100. Let's make it 100 point. Okay? When I go to multiply this, I have 1, 2, 3, 4, 5 significant digits. So all of these are significant. So what I would include the point. Or on the other hand, what if I have less significant digits than I'm given? Let's say it's 4.2 times 6. I have 12, 25, 25.2. This 6 is there's only one significant digit in this number. This one has two significant digits. Your answer can only have as many digits significant as the least significant because you're limited by your least significant measurement. So I can only have one significant digit. So this 5 would round the 2 up to 30. So that would be my answer because I can only have one significant digit. Let me give you one more of these multiplication ones and then we'll do a couple of addition ones. What if I had 51 times 2.2? All right, we'll do 510 times 2.2. So we do multiplication, add it up. I have a decimal here. I have 2 significant digits here, 3 significant digits here. This is my least significant. It has the least number of significant digits, so I can only have 2 significant digits. So this would actually become 1.1 times 10 to the 3rd. So that would be the answer to that. I would just write it in scientific notation and make sure I only had 2 significant digits. Now let's look at one example when you add and subtract. Let's say I'm adding 27.2 and 6.89 and 53.421. Okay, I'm adding those numbers up. I have a 1, 11, 15, 10, 17, 8. Well, the number that has the least number of significant digits in the decimal is this one. So this is the one that limits my answer. I can only have one decimal place because that was my least accurate tool. All these others, they were very accurate, but with this tool, I only had one decimal place. So my answer can only have one decimal place. So my answer is 87.5. When you go to add again, I'll just do another example for you, okay? Let's say I'm doing 50 plus 65.2 plus, I don't have to have another plus, just those two, okay? When I go to add it up, again, this is my answer. However, this measurement does not have any significant decimal places. So you can't have a decimal place in your answer because your tool was not that accurate. It didn't measure all the way down. So I only have one significant digit here. And there's no decimal place. So I cannot have a decimal place. So my answer is 115. Okay? So when you're adding and subtracting, the number of significant digits really depends on the decimal places. The least number of decimal places that are significant, that's what you're going to use. When you're multiplying and dividing, you look at all the numbers. Whichever number has the least number of significant digits, that's the one that limits you. So if you have 3 significant digits in your least number, you can only use 3 significant digits in your answer. Right? I hope that helps you. It really is a way to be accurate based on your tools, because you can't say you measured something to the nearest centimeter when your tool only measured meters. In other words, you've got to represent your measurements and their accuracy. That's why it's very important for you to actually write everything down. So if you have a meter stick and it's right on the line, then you always include the 0.0 because you're saying it went right on the line, that whatever you measured went right to the line. So you want to make sure that you include that. If it's right on the line, you add that extra place at the end so that we know that it was right on the line. All right, I hope this helps you, and again, if you have any difficulties, make sure you come and see me, because I don't want you to be confused about this. It's a pretty easy topic. You just got to get used to using significant digits. Have a great night.